I'll skip the introduction, but basically I'm Dan Kahn. I am here to talk about my final project. As people have already described, the class project was to take this Raspberry Pi, like we're seeing on the screen here, add the little Zigbee Kahn B2 dongle off of it, connect it to both a light and to one of these Acura sensors that measures temperature, humidity, and pressure. And then take that information over the web to IoT Creator, where the data is stored in MQTT, in an MQTT queue and in DynamoDB. And then display the data on a dashboard, which looks like this. And then add some controls where you can turn the light on. If you can see over my shoulder here, the light's turning on. Can you see my screen? Can you see my?
Yes, we can.
Light turns on and off, or I can control the brightness of the light using a slider.
Very cool.
And I'll get to the rest of this in a minute. And then, so that's, that basically sends commands back to the Raspberry Pi, which turns on the light or turns off the light. Now I started thinking about how I could use this to expand it, and I started especially thinking about the situation that we're in right now, and realized that since we've been sheltering in place, my two teenage boys have basically gotten into the habit of going into their rooms and closing the doors and sheltering in there for hours on end. And every time I opened the door, it was hot and muggy and humid in there. So what I wanted to do was take this and build something on it to control the temperature in their rooms, because even though we have an IoT-based temperature controller for the entire house, it wasn't really working for individual rooms when those rooms are closed off. So I put the sensor in their room. I determined a baseline humidity that they would get to when it got uncomfortable, when it got really, really uncomfortable. You know, through our dashboard, my dashboard, I captured that over time. And what I decided to do is I added one of these Zigbee controlled plugs to my system, which controls this Vornado just regular fan. And every time that the the humidity got above a certain level, the fan will turn on. And if it got really, really bad, then the light would turn on as well. And in fact, it just turned on because my humidity grew above a certain level. So you can see it's done now. And I decided that I wanted to be able to see why it's turning on. So I added these LED lights, which you can see in my mock-up here. And I can see that it's only a little bit humid in here. So the fan is on and the yellow light is on. If I really blow into this, it'll take a few seconds. The light goes on and you can see that the red LED turns on, indicating that it's really hot and uncomfortable in here. Now, I got to a point where I really wanted to be able to turn these things off, because if I manually, so I added these buttons that turn off the fan and the light, so that you don't have to go onto be near your phone and such to connect that, to control those. And finally, I try to do something with time of day, in that I didn't want to turn on the lights during the day because, well, it's waste of energy and such. So I went to a website and pulled down the sunrise and sunset times for today. For each, I pull it down for each day, and based on the time of day, the light bulb won't come on. And the idea here is that what I would do with these next is I would start to add more to this. First thing I would do is I would re-architect it for scalability. I need to be able to add and remove sensors and actuators so that I can control multiple rooms, and that can be isolated by closing the doors. Like in my case, I have 2 kids, but some people have more, some people have less, so it has to be scalable along that line. I also have to add scalability to the actual HVAC control law, because if some rooms are getting hotter than others, then I need to be able to still turn on the air conditioning and appropriate direct air into those rooms. And the other part of re-architecting it would be to find a more reliable database storage solution. I think Rudy will agree that DynamoDB has been a little flaky for us. The other thing I would want to do is develop some different actuators. The fan is good, but what I'm really thinking about is something along the lines of an inline, an induct fan that will direct more of the HVAC forced air into the rooms that need it the most, based on the sensor readings. And the control law for that is probably going to be the biggest part of this. And then as we also learned today, the next thing, one of the other things we have to do is improve the network security and data privacy of the code, because I like to store all my stuff on GitHub, and when I did that today, I almost brought down everyone's project. So I apologize for that, and we took care of it. So hopefully no one was impacted, but it's definitely something that we would have to look at more carefully. And that's my presentation.